Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, we will discuss some of the exam questions on the topic called light and electromagnetic spectrum. This question is associated to the potential dangers of electromagnetic waves. In our last video, we have seen that the order of EM spectrum is RMI, VU, XG, and as you go from radio towards gamma waves, your frequency increases and they carry more energy. Hence, they become more dangerous. We can say they become more dangerous if the frequency increases. So the answer for this question will be B. Next question says, which ray diagram shows total internal reflection at an air and glass boundary? At an air and glass boundary. Now you need to remember, this question is about total internal reflection. So there are two conditions. Number one, it must travel from glass to air. So it's more dense to less dense. And number two, angle I must be greater than critical angle. And in that case, total internal reflection will take place. Therefore, I can say, in this case, I can see it travels from glass to air. This is fine. Travels from glass to air, fine. Here it is traveling from air to glass. This is wrong. This is wrong. Now let's quickly have a look at the option available. In this case, the angle I is not same as angle R. So this is wrong. In this case, this is my angle I and this is my angle R. When total internal reflection will take place, your angle I will always be equal to angle R because the law of reflection will apply. Next question, it says a student is investigating the refraction of light. Figure 5 shows part of the apparatus and the angles to be measured. This question is about refraction, so you have to remember this equation, V equals F times lambda, because this will play an important role. And our frequency in this case is always constant because it depends on the source. So I can say if my speed increases, my wavelength will increase. If my speed decreases, my wavelength will decrease. Here it has traveled from air and this is glass. So it says the frequency of the light remains the same in glass as in air. Which row of the table describes what happens to the wave velocity and to the wavelength? You've just seen it on the last page. V equals F times lambda. This is constant. When the light will enter into glass, the velocity will decrease and so will the wavelength. So the answer in this case will be A. Next question again is about refraction of light. So you have to remember this is air, this is glass, and then this is air. So here it will be fast, it will be then slow, and then it will be fast again. It says which of these sketch graphs represent the speed of light as it travels from P to Q. So remember, because this is air and air, same material, therefore speed will be same. So what will happen? It will first slow down and then it will speed up again. But the starting and the ending speed will be the same. So the only option that's correct in this case is B. This question says which color of the visible light has the longest wavelength? So you have to recall that Roy G Biv. And the order is in this direction, the wavelength is decreasing. My frequency is increasing and so is my energy. Say the longest wavelength will be out of these colors, it will be red. Next question says a student investigates how different surfaces radiate energy as they cool. Figure 9 shows some of the apparatus used in a part of investigation. We are looking at how they cool. So this means this has to do something with temperature. Now, if you look at this apparatus carefully, there is no thermometer. So there will be one mark for saying that you'll have to measure temperature. Let's see what the question says. The question says, describe how the student could collect the data to show how the rate of cooling of the container and water change with time. So basically they are saying, work out how the temperature changes over time. Now in this case, because it says changes with time, this has to be continuous data. So it says how student could collect data. So we'll say he should use thermometer. Record temperature over regular intervals. Okay. Next question. A student looks through a blue filter at a green leaf on a white background. So I've got a plate here, this is white. Here is a leaf, this is green. And it says the filter here is blue. And here is someone who is looking at it. Now the white light will fall on the white plate. The white plate will reflect all colors, but only blue color will pass through the blue filter. So the white background will appear blue. So we can say white background will appear blue. It says describe the colors that the student sees. So white background will appear blue. How about the green leaf? When the white light falls on the green leaf will absorb all colors, but it will only reflect green light. When the green color gets reflected, it can't go through the blue filter, so none of the colors will reach from the green leaf. So the leaf will appear black. Next question. Figure 3 shows an image taken at night using a camera that is sensitive to infrared radiation. Now they've given you information. It will detect infrared radiation. Radiation with shorter wavelengths show as brighter areas in this image. Explain why the people can be seen against the background in this image. Because in this case we can say people have temperature which is greater than environment. Number 1. Number 2, we can say therefore they will emit shorter wavelengths. Okay, so the body will emit shorter wavelengths, which is detected by the infrared radiation camera, and as a result of that it will show the image. Next question. The following arrangement is used as a solar powered shower. The bag is left out in the sunlight during the day. Explain what color the bag should be to heat the water to highest temperature. To heat the water to highest temperature. This question is about the properties of surfaces. In this case, you have to remember dark and dull colors are good absorbers. They are also good emitters. So in this case, we can say it should be black, because dark colors are good absorbers. Okay, this is important word here. Dark colors are good absorbers. This is something what it will do is it will absorb more energy, and therefore the temperature will increase. Next part says, on a sunny day the bag is filled with cold water. Explain why the temperature of the water increases and then stays constant. So when it is increasing, I can say it absorbs more energy than it emits. Here I'll say emitted energy will be equal to absorbed energy, but they both have to be in 1 second. In 1 second. That's important, because we are saying the amount of energy that it absorbs in 1 second is more than the amount of energy that it emits in 1 second. Here we are saying the amount of energy that it emits is equal to the amount of energy that it absorbs in 1 second. So the energy going in is equal to the energy that's going out, therefore the temperature stays the same. Next question. A specific electromagnetic wave has a frequency greater than visible light. The wavelength of this wave is longer than the X-rays. So if I recall my word, RMIVUXG, it says it is greater than visible light. This means it is over here, because if you remember, we said in this direction your wavelength decreases, your frequency increases, and your energy increases. Let's have a look. It says a specific wave, electromagnetic wave has a frequency greater than visible light. So when do I have frequency greater than visible light? It will be after visible light. So there are 3 options: ultra, X-rays, and gamma rays. But the next part says the wavelength of this wave is longer than the X-rays. Wavelength is increasing towards the left. So which one is it? It's going to be the UV light. It says the electromagnetic wave is an ultraviolet wave. Next question says the picture shows a woman checking that a banknote is genuine. She's using a lamp which emits a radiation which is part of electromagnetic spectrum. Explain how two different electromagnetic radiations enable the woman to check the banknote. Now you need to remember one thing. Our eyes can only detect visible light. So this is visible light. So we can say banknote emits visible light. Number 2, we can say the lamp emits UV light. Now what is happening here? When the UV light will fall on the banknote will absorb some energy and it will emit visible light. Note absorbs some energy. And then what happens? It emits visible light, and that visible light is now can be detected by humans. Next question. In figure 7, only refraction of light is shown. Other things happen to the light as it travels from P to Q. The intensity brightness of the light at Q is less than the intensity of the light at P. Explain the decrease in intensity as the light travels from P to Q. This is our boundary. So we know at a boundary certain things happen, right? Number 1, we can say part of light is reflected at a boundary between P and between air and glass. Number 2, we can see the light enters into the new material, so transmission is taking place, and we learned when transmission takes place then some of the light also gets absorbed. So we can say some energy gets absorbed by the glass. Next question. Figure 13 shows a semicircular glass block. Describe how a student could use the semicircular glass block and other apparatus to determine the critical angle for a glass to air boundary. Critical angle. Recall what is critical angle. Now critical angle is the angle of incidence for which angle of refraction is equal to 90. That's how the critical angle is defined. So what will you do? It says you should add to the diagram in figure 3 to help your answer. So I can say this is my center. This is my center of the semicircle. And I can say I can draw a normal line here. This is my N. And from here along the radius I will then shine light. So this is going to be light ray. Maybe angle. I've drawn this much diagram. All I'm going to say now is I'll say increase angle I until, here's my normal, here is my angle R, right? Until angle R is equal to 90. I'll say measure angle I, this is equal to critical angle. Then I'll say repeat. So not a difficult question, but look, it carries 4 marks, right? So important from your exam point of view. Next question. Ultraviolet waves cover a range of frequencies. Scientists divide this range into 3 types: UVA, UVB, and UVC. The table in figure 14 shows the frequency range for each type. So if I look at it, I can see this is 7.5, 9.4, 9.4 to 10, 10 to 13. So as I go down, my frequency is increasing, therefore my wavelength has to decrease, okay? Because that's what we know. If frequency increases, then the wavelength will decrease. Now, it says figure 15 is a diagram about the effect that the Earth's atmosphere has on three types of UV radiation. So we've got UVA, UVB, and UVC. So I can look at it and I can say this one has shortest wavelength. This one will have the longest wavelength. It says describe how the effects change with wavelength using information from figure 14 and figure 15. The width of the arrows drawn indicate the amount of radiation that is involved. Calculations are not required. It's a 4 marker. So I'll say for UVA, what is happening? It enters from one material to another. So I can say most is transmitted, some is absorbed. For UVB, I can say small amount is transmitted, because you can see it has passed into the new material. Most is absorbed. And then I can say about UVC, small portion is reflected, majority of it is absorbed. So you can see they all have one thing in common, that is they are being absorbed. So I can say as wavelength decreases, absorbance increases, right? And that will get you the 4th mark. Next question. A student investigates how light is reflected from a plane mirror. Figure 4 shows part of the student's investigation. Complete the diagram to show the normal, the angle of incidence, and angle of reflection. Now you need to remember one thing, normal is always at 90 to the surface. So here is my surface. I can say my normal line will look like this. Then next bit, all angles are with respect to the normal line. This will be called angle of incidence, and this will be called angle of reflection. Last question on lenses, and that would be the end of this question booklet. The diagram shows the formation of an image produced by one type of lens. This is my diverging lens. We learnt earlier that diverging lenses, they always produce upright, diminished, and virtual images. It says on the diagram, draw and label the image produced. Where these two lines are meeting together, this is where my image is. Part done. Then it says on the diagram, show and label the focal length of the lens. So this is where my focal point is. This is my center of lens. The distance between them two will be my focal length. Okay. I've done a couple of questions on this topic. I hope you will find this video useful. I wish you all very good luck with your exam preparation. Thank you.